In this video, we're going to wrap up our discussion of representing systems of linear equations with matrices by doing some application problems, some word problems. In each of these examples, there'll be three unknowns, there'll be three variables. And so in order to be able to solve these problems, we're going to have to tease three equations out of the given information. Once we've got that system of equations, we're going to represent the system with a matrix, and then we'll use the calculator to come up with the solutions. Let's just jump right in. A candy store owner is creating a special 8-ounce mix of candy from their three personal favorite minis in their shop, named X, Y's, and Z's. The X costs 50 cents per ounce, the Y's are $1 per ounce, and the Z's are $2 per ounce. They're overstocked on Y's, so they're going to throw in twice as many of the Y minis as of the Z's minis. If they want to charge $7 for the mix, how much of each candy should be used? Okay, there's a lot of information here that we're going to have to organize into equations. And in order to be able to write those equations, we're going to need some variables. It's usually best practice to let the variables represent the things that you're looking for. We want to know how much of each candy should be used, and so we need a variable for the number of ounces of each type of candy. I'm pretty lame, so I'm just going to use the variables X, Y, and Z. So I'm going to let X be the number of ounces of the X candy. I'm going to let Y be the number of ounces of the Y's. And I'm going to let Z be the number of ounces of Z's. Now that we have these symbols to represent these unknowns, we're going to see if we can translate some of the given information into equations. At the start of the problem, we're told that the owner is creating an 8-ounce mix of the candy. So the total number of ounces of candy needs to be 8. In other words, if we add the number of ounces of each candy used, it should total to 8. X plus Y plus Z should be equal to 8. Now we have an equation that relates the weight of each candy to the total weight of the mix. Let's see, what else do we know? We know that the X costs 50 cents per ounce, the Y's cost $1 per ounce, and the Z's are $2 per ounce. And that the total value of the mix is to be $7. So the value of the X would be 50 cents times X. The value of the Y's would be $1 times Y. And I know we don't need to write that one, it would be implied, but I want to show my work here. And it's $2 for each ounce of Z's. This sum would be the total value of the candy in the mix, and we know that they want to charge $7 for that mix, so this should be equal to 7. So we've got two equations, but we're going to need to find a third, because if you want a system with three variables to have a unique solution, you need at least three equations. So what else do we know? Oh, right, they're going to throw in twice as many of the Y minis as of the Z minis. Now I've written that phrase on the screen here so that we can talk about how we translate this into an equation, because a lot of people get this backwards. It says twice as many Y's as of Z's. That does not mean take 2 times the number of ounces of Y's though. When we say we have twice as many Y's, that means the weight of the Y's is 2 times the weight of the Z's. The number of Y's is the larger number. So if I want to express that there are twice as many Y's as Z's, I would write Y equals 2 times Z, not 2Y equals Z. Now we have our system, and if we were going to use a substitution method, we'd be good to go. But because we're going to use a matrix representation, we're going to have to alter this last equation. When you're using the matrix representation for a system of equations, you need all the variables on one side and a constant term on the other side. So I'm going to have to subtract 2Z from both sides of the last equation in order to get this into a format that I can put into a matrix. First equation stays the same, X plus Y plus Z equals 8. Second equation is still 0.5x plus y plus 2z equals 7. I've now dropped the unnecessary 1, although we're going to bring it back for the matrix representation. And the last equation is y minus 2z equals 0. We now represent that with a matrix. 1, 1, 1, 8, 0.5, 1, 2, 7, and 0, 1, negative 2, 0. We're ready to put this into the calculator. We're going to access the matrix screen by pushing second and the X inverse key. We want to start by editing a matrix. I'm going to edit matrix A. My matrix has 3 rows and 4 columns. Our first row was 1, 1, 1, 8. That was for the number of ounces of candy. Our second row was 0.5127. That was for the value of the candy. And our last row was 0, 1, -2, 0. And that was our way of saying that we have twice as many y's as we do z's. I quit back to the main screen with second and the mode key. I bring up those matrix options again, second and the x inverse key. And we're going to do some math. In particular, we're going to put this in reduced row echelon form. So I scroll to the math heading, and RREF, reduced row echelon form, is choice B. If you're going to scroll to it, it's faster to scroll up. Alternatively, you can just push alpha and the apps key in order to access option B. One last time to the matrix options, second and the x inverse key. I put the name of the matrix that I want to put in reduced row echelon form inside the parentheses, and I hit enter. And we get the matrix 1004.4, 0102.4, and 0011.2. Translating that in terms of the variables, that means x equals 4.4 ounces, y equals 2.4 ounces, and z equals 1.2 ounces. So they should use 4.4 ounces of x, 2.4 ounces of y's, and 1.2 ounces of z's. Let's try a similar problem, and this time I'm going to have you try to come up with the equations. This says a jar contains an assortment of nickels, dimes, and quarters. There are 300 coins in the jar with a total value of $45.60. The number of quarters is 4 times the number of dimes. How many quarters are in the jar? Now here, there's only one question being asked, and that's how many quarters, but we also need to figure out how many nickels and dimes there are. So we're really going to use 3 variables. I would personally let x be the number of quarters because that's what we've been asked to find, but you could let x be the number of dimes or the number of nickels. It doesn't really matter. Just make sure you have a variable for each. So I'm going to go back to the problem, point out a piece of information, and ask you to translate that into an equation. I see that there are a total of 300 coins in the jar. Using our variables, express that there are 300 coins in the jar. Since x, y, and z each represent a number of coins, we just have to add up those numbers to get the total number of coins in the jar, which is 300. X plus y plus z equals 300. We know the total value is $45.60. Using the fact that a quarter is 25 cents, a dime is 10 cents, and a nickel is 5 cents, come up with an equation that tells us that the total value of the coins is $45.60. We're just going to multiply the number of quarters by the value of a quarter, so 25 cents times x, the number of dimes times the value of a dime, so 10 cents times y, and the number of nickels times the value of a nickel, that's 0.05 times z, and that has to give us the total value of the jar, which is $45.60. The last bit of information is that the number of quarters is 4 times the number of dimes. Unlike our first example, this one is a pretty straightforward translation. The number of quarters is 4 times the number of dimes. The number of quarters is the larger number because we're going to multiply the smaller number by 4 in order to reach that value. Now we have the system, but in order to put this into a matrix format, we have to alter that last equation. See if you can do that. Look back at the last example if you need to. We're not going to do anything to the first 2 equations because all of the variables are already on the left with a constant term on the right. So I'm just going to recopy those first 2 equations. The last one has variables on both sides though, and while that's not a problem for like the substitution method or something like that, we can't do that in the matrix format. We need to get all the variables to one side. So I'm going to subtract 4y from both sides and get x minus 4y equals 0. Now we can translate this into a matrix. See if you can do that. The first row would be 1, 1, 1, 300. The second row would be 0.25, 0.1, 0.05, 45.6. And the last row would be 1, negative 4, 0, 0. Put that into your calculator and use RREF to get this into reduced row echelon form. Okay, so I've already typed in all of the information. You can't see my last column, but I promise you that I have those in there. I quit back to the main screen and run RREF, and we get the matrix 1, 0, 0, 144, 0, 1, 0, 36, and 0, 0, 1, 120. Remember, the question was to figure out how many quarters there are, and we called the number of quarters x, so it's going to be that entry in the first row. We know x equals 144. There were 144 quarters. Now, I fully admit that example is not very realistic. It would be weird to know that there are 4 times as many quarters as dimes in the jar, or to know the value of the coins in the jar without knowing how many of each there were. The next example, however, is a real-world example. This is something that I've actually done. During a recent weight loss program, I tried to adhere to 3 rules. I wanted to eat an equal number of grams of protein and carbs, so I was trying to keep protein and carbs the same. I wanted to get twice as many calories from protein than I did from fat, and I tried to restrict myself to 1,800 calories per day. Now, what I wanted to do is know how many grams of carbs, how many grams of protein, and how many grams of fat I should eat. And in order to do that, I had to use this fact that you see here. It is well established that fat has 9 calories per gram, while carbs and protein each have 4 calories per gram. Let's use this information to determine how many grams of protein, carbs, and fat I should consume in order to stick to these rules. So if I'm trying to track these macronutrients when I eat, I need to know how many I should aim for. Let's set up a system of equations and figure out how much of each of these macronutrients I should have. First, I need some variables. The goal of the problem is to determine how many grams of protein, carbs, and fat I should consume, and so that's what I'm going to let my variables represent. Let's go back to the problem. My first rule was that the number of grams of protein and carbs should be the same. That equation is pretty straightforward. The number of grams of protein should be equal to the number of grams of carbs. So x is equal to y. My second rule is that I want to get twice as many calories from protein than fat. That's a tricky one. We'll come back to that one. I had a target of eating 1,800 calories per day. Fat has 9 calories per gram, while carbs and protein have 4 calories per gram. So if I take 4 times the number of grams of protein, plus 4 times the number of grams of carbs, plus 9 times the number of grams of fat, that needs to add up to 1,800 calories if I reach my goal. Now let's go back to that second one. I want to get twice as many calories from protein than fat. I'm going to write that out. Now, translating this sentence is going to be tricky for 2 reasons. One, we have that same issue with the twice. Right? Where do we multiply by 2? We also have to pay attention that we're doing twice the calories, not twice the grams. So first we need to start with the number of calories from protein. That's not x, that's just the number of grams. How do we get the number of calories? Remember, we multiplied it by 4. 4 times x gives us the number of calories from protein. That has to be equal to 2 times the number of calories from fat, because we're getting twice as many calories from protein as we are from fat. So I take 2 times the number of calories from fat. That's not 2 times z, that's 2 times 9z. So simplifying this system, we get x equals y, 4x plus 4y plus 9z equals 1,800, and 4x equals 18z. See if you can shift around some terms so that we can put this into a matrix format. You want to subtract y from both sides in the first equation. We're not doing anything to the second equation. And you want to subtract 18z in the last equation. Now we can represent the system with a matrix. The first row would be 1, negative 1, 0, 0. The second row would be 4, 4, 9, 1,800. The last row would be 4, 0, negative 18, 0. And now we're going to get that into reduced row echelon form using the calculator. Okay, so you can see everything except my last column typed into matrix A here. My last column is 0, 1,800, and 0. When we quit back to the main screen, you'll see I've already run the reduced row echelon form function. And we get 1, 0, 0, 180, 0, 1, 0, 180, and 0, 0, 140. So x equals 180, y equals 180, and z equals 40. So I want 180 grams of protein, 180 grams of carbs, and 40 grams of fat in order to follow those 3 rules. You can see that I've satisfied the first rule. The number of grams of protein and the number of grams of carbs were the same. It also says I should get twice as many calories from protein as I do from fat. If I've got 180 grams of protein and I multiply that by 4 calories per gram, that's 720 calories from protein. I have 40 grams of fat, but fat has 9 calories per gram. 40 times 9 is 360, and 720 is 2 times 360, so I'm getting twice as many calories there. And you can go back and check that that adds up to 1,800 calories total. And this is how I set up that diet plan. Now I have to admit, I did not figure out how many grams of each to use by setting up this exact system. My method for figuring this out was a little bit different, but I did use algebra. I didn't just guess and check. So maybe not the most interesting example, but at least it's a real world example. This is a place where I actually used algebra in everyday life. Doesn't come up very often, I admit, but this was one place where it did for me. Now let's go from a real world application problem to a purely mathematical problem. A parabola passes through the points 1, 0, 2, 11, and negative 1, 2. Find the equation of the parabola. Now there are real world problems that are like this, but they're not everyday problems. This would be related to like tracking the trajectory of a projectile or something like that. That's not something most of us need to do in our everyday lives. I've taken all of that context out of it and just said, let's find the parabola. Now, how are we going to do this? Well, we need to fall back on a fact that we learned earlier in the course. The type of function that's going to give us a parabola is f of x equals ax squared plus bx plus c, where a is not equal to 0. We know that's the equation of a parabola. What we need to do is figure out what a, b, and c are, so those are our unknowns. I don't need to write let statements here. I've made it pretty clear that a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. But where are we going to go from there? Well, remember that these points are basically telling us inputs and outputs. Like the first point, 1, 0, that's telling us that when the input is 1, the output is 0. So let me plug 1 into our function here. I get a times 1 squared plus b times 1 plus c should be equal to 0. Simplifying that, I get a plus b plus c equals 0. There's our first equation. Let me do the same thing for the second point, 2, 11. That's just another way of saying that f of 2 is equal to 11. Let me just plug 2 in for x, so I get a times 2 squared plus b times 2 plus c is equal to 11. Now I'll just simplify this. 2 squared is 4, so this is 4a. Rather than writing b times 2, we would typically write 2b plus c is equal to 11, and we have a second equation. See if you can use the last point to come up with a third equation. So the third point is telling us that when we plug negative 1 in, we should get 2. F of negative 1 is equal to 2. So a times negative 1 squared plus b times negative 1 plus c should be equal to 2. Negative 1 squared is 1, so the first term is a. B times negative 1 would be minus b plus c equals 2. And now we have a system of equations. Let me stack the equations on top of each other on the next slide. Here are our 3 equations, and it's already organized the way that we need for a matrix representation. So come up with the matrix, use RREF in the calculator to come up with the values of a, b, and c. So here's the matrix representation of our system: 1, 1, 1, 0, 4, 2, 1, 11, and 1, negative 1, 1, 2. You can see I've already typed that into matrix A. You can't see my first column, but I promise you it's in there. I'm going to quit back to the main screen, second in the mode key, and I'm going to run this RREF function. Pull up the matrix options again. Go to Math. I want choice B, reduce row echelon form. Matrix options one more time to put in the name of the matrix, and we get 1, 0, 0, 4, 0, 1, 0, negative 1, and 0, 0, 1, negative 3. Remembering that these are a, b, and c respectively, that tells me that our function is 4x squared minus x minus 3. This is the only parabola that goes through those 3 points because we got a unique solution. You're definitely going to want to find some more examples to practice. I encourage you to find a textbook that's got some good examples in it and do some from there. If you have questions about the examples that you're trying or any of the examples that I did in this video, please reach out to me either by email or see me in an office hour.